Hello my dear students, in this lecture we are talking about the moment of inertia of solid sphere. Okay. Solid sphere is kind of rigid body. So, we have to use formula of rigid body to find the moment of inertia. Okay. So, moment of inertia of any rigid body, what you have to do? You have to do integration of r square with respect to m. It is the formula to find the moment of inertia of any rigid body. Now, if we having a solid sphere and we have to find the moment of inertia of any axis which is passing through the center of mass. This is the axis passing through center of mass. Okay. And we have to find the moment of inertia of this solid sphere having radius capital R and mass. We can write here radius. What is the radius? It is capital R and mass it is capital M. Okay. So, what we have to do? We have consider some differential disk. We have to consider differential disk. So, let us consider a differential disk at height y from the center having thickness dy. Okay. What we are doing? Consider a differential disk of thickness dy at height y. Okay. Now, we have to find the differential mass of this differential ring. So, the differential mass dm. So, how we can find the differential mass? By using total mass divided by total volume into differential volume, because mass is distributed over the volume here. It is solid sphere and mass is totally distributed over the volume. So, total mass divided by total volume into the differential volume. So, what is the differential volume of disk? It is the differential volume total area pi r square into thickness dy. This area pi r square, okay, and the radius is small r. Since we have to move this differential disk from bottom to top, so here y equal to minus r at the bottom and the highest point y equal to plus r. Okay. And here the radius will also variable. Okay. Radius is also changing. That is why we have to find the relation between y and the radius of the disk. So, here these all three quantity r, y and capital R making right angle triangle. So, you can use y square, Pythagoras theorem, r square is equal to capital R square. So, this small r square is capital R square minus y square. We have to use this formula, this relation, because these are both are small r and y both are variable. Okay. But we have to do integration only with respect to one parameter. So, this dv is equal to pi r square into dy. Now, we can put dm is equal to total mass divided by total volume is 4 by 3 pi r cube into differential volume pi r square into dy. This pi will cancel out and dm is equal to 3 capital M divided by 4 r cube into r square into dy. Okay. Now, what is the moment of inertia of differential disk? Moment of inertia of differential disk. It is di is equal to, you know very well, the moment of inertia of disk is mr square by 2. So, mass is dm, radius is r square, small r square divided by 2. So, here di is equal to, what is the value of differential mass? It is the 3 m r square into dy divided by 2 r cube into r square, this radius r square divided by 2. So, here we are getting 3 capital M r raised to power 4 into dy divided by 4 r cube. Sorry, it is 4 r cube. So, 4 r, it will become 8 r. Okay. Now, we have to do integration. So, total I is equal to 3 constant, m constant divided by 8 r cube is constant, and what is the r raised to power 4? This r raised to power 4 can written as r square whole square, because we have to do integration with respect to y. So, we can use this relation r square is equal to capital R square minus y square. So, this small r square can written as 3 m divided by 8 r cube integration r square minus y square into dy from y equal to minus r to capital R. Okay. Is this clear to all of you? Now, whole square also there. Okay. We have to do integration of this expression. So, let us see. So, this square r square minus y square whole square we can open, okay, and we will get I is equal to 3 capital M by 8 r raised to power 3 r raised to power 4 plus y raised to power 4 minus 2 r square y square, okay, integration from minus r to r with respect to y. Since it is an even function, it is an even function. So, we can write 2 into 3 m divided by 8 r cube integration from 0 to r. This concept you have to understand. What you have to understand? This I am cleaning the board. Okay. What you have to understand? It is an even function because y raised to power 4 is even, y square is also even. So, it is even function. If we are putting minus y, we will get again same expression. So, it is even function. So, what you can do, integration from minus r to r can convert 2 into 0 to r. Okay. So, I am multiplying 2 and integrating from 0 to r of r raised to power 4 plus y raised to power 4 minus 2 r square y square into dy. Okay. So, it will become 3 m by 4 r cube, this 2 and 8 will cancel by 2 and we will get 4. R raised to power 4 having integration r raised to power 4 into y, and y raised to power 4 having integration y raised to power 5 by 5. Okay. Y raised to power 5 by 5 minus 2 r square y raised to power 3 by 3. What is integration of y square? It is y raised to power 3 by 3 from 0 to r. Now, we are putting the limit. So, I is equal to 3 capital M divided by 4 r cube. Okay. First upper limit. So, what you have to do? You have to replace y by r, and then lower limit, it will become 0. So, it will become r raised to power 5 plus r raised to power 5 by 5 minus 2 by 3 again r raised to power 5, and we can take common r raised to power 5. So, we will get I is equal to 3 m r raised to power 5 divided by 4 r cube. This r cube and raised to power 5 will cancel out and we will get r raised to power 2. So 1 plus 1 by 5 minus 2 by 5 will be remaining in the bracket. I is equal to 3mr square by 4, and after getting LCM we will get it is 3. 15, so 15 plus 3 minus 10. So finally we are getting 15 plus 3 is 18 minus 10 is 8. So I equal to this 3 will cancel out by 15, we will get 5. Okay. So mr square into 8 divided by 4 into 5, 2 times cancel, so it will be 2 by 5 mr square. Okay. So the moment of inertia of a sphere, solid sphere is 2 by 5 mr square. It is very easy to understand. Thank you very much.